Okay, so good morning to everybody who's here. I'm going to give us just a couple more minutes for additional people to arrive because last week there was a lot of us. Hello, Hayden.
Hi, morning.
As last week, we've got Hayden as a teaching assistant here who you can talk to either via direct message or on the chat for the entire class, and she'll try and answer any specific questions that you've got. If you've got any questions for either of us, just put them on the chat, raise your hand, take yourself off mute and tell us. We're up for anything. It can be about the content of the course, it can be about the focus on the webcam, which I realise is quite bad, about the visualizer, about any kind of logistics. If it's about logistics, we might just have to shout for some of these to give us some insight, but we'll try our best. So we've got a lot more people joining, so I'm still going to leave people with another couple of minutes to arrive because, yeah, seems like a plan. Okay, so I think we should get started. So welcome. It's Intro to Stats at 9 o'clock in the morning on Tuesdays. I'm also the teacher for Thursdays, 4 till 5 and 5 till 6. And my understanding is that Sarah Lee is happy with you attending any of the classes. But you will probably have been allocated one by the TLO as well, so feel free to attend whichever one suits you best. We are doing exercise sheet 4, and all of the questions were about 5 statistics summaries of data, histograms, and the odd box and whisker plot, and a little tiny bit of theory in there as well. So the format is going to be really similar to last week. I'm going to run through some of the questions. I'm going to leave some gaps for you to have a go at some of the calculations, you know, once I've, you know, illustrated what you need to be doing. You can ask questions. Hayden's here, you can direct message her or message her in the chat with any questions that you've got, either about what I'm saying or generally about the course up until this point, and I'm sure she'll do her best to help you. In fact, she won't just do her best, I know that she will be able to help you, definitely. So just keep in touch with us, don't be silent, at least think along with us, and we'll crack on. I'm still having the odd person join us, so if I break off slightly, it's probably because I'm letting somebody in. We just had some lovely household noises from Sarah Lee's, and you might get some from me as well if the baby wakes up. Fingers crossed she doesn't. Okay, so let's switch to the visualizer. Okay, so I think the questions I wanted to focus on was, I was thinking question 1, question 2, question 5 and question 6. And I think by the time we get to dealing with question 5, you guys should be really, really swift on what you need to be doing here. All right, one more person who needs to be let in. So question 1, let's have a look at question 1. Hopefully that's nice and in focus for you. So we were given 25 data points by Sarah Lee's, and we were asked to find some of the quartiles of the sample. So we were asked to find Q hat P, which is our symbol for the pth quartile or pth percentile of the data. And we were asked to find the value of this for P equals 0.1, P equals 0.25, and 0.5 and 0.75, and finally the 90th percentile as well. So these were all relatively straightforward if we could interpret what the formula was, and the formula that we were given involved R, and what R is R is P, and we need to multiply that by n plus 1, where n is the number of elements in our sample. So in this case, n is equal to 25 because we were given 25 data points. So for the first one of these values that we were asked to calculate, the 10th percentile, we need to put P is equal to 0.1 into this formula. So we end up with, in that case, R is 0.1 times 26, which is 2.6. Now, if a whole number comes out here, we can just take the percentile in question to be that element in the ordered sample. But in this case, we can't, so there's a slightly more complicated formula. So for this R, we know that Q, Q 0.1 is equal to X, and we need to take the second element in the ordered sample. That's why there's little brackets there. It's because we're talking about the ordered sample, and then a weighted average between the second and the third to put us at approximately 2.6, the 2.6 element in the ordered sample. So we're going to have 0.6 and then X, the third element in the ordered sample, minus the second element in the ordered sample. So if you take a look at the data points we were given, what you will see is that the second element that we were given was 0.2290, so 0.2290, and the third point was 0.6390. So if I plug both of those two in and get my calculator out, I'm going to find that the 10th percentile of the sample is at 0.475. Okay. Right. So that's nice. We've managed to do one together. So in order to do the 25th percentile, the next one that I've been asked to do, I'm going to need to change P in this formula to 0.25. And I'm going to end up with R is equal to 0.25 times 26, which is 6.5. Okay. So for R is equal to 6.5, the 25th percentile is going to take a similar form. So I'm going to need to put the sixth element here, and then I'm going to have the 0.5, the rest of the 6.5 then. Right, so the non-integer part of this number, and then x7, this one. Okay, so I'd like to just give you a moment now to take a look at the sample set on the exercise sheet and to complete the rest of that calculation to find the 25th percentile. So I want to leave you with, I think, probably about a minute in order to get that one out. When you've found the answer, you can direct message me the answer. And once I've got a few, we'll carry on to the next part. Okay, so I'm hoping that when you were looking at the question, you were counting along to the sixth element of the sample, because the sample's already ordered for us. And we had the sixth element in the ordered sample is 1.8529, which is the final entry on the top line. And then we also wanted, half. Just got extra people to let in, half of the difference between the first element on the second line and the final element on the first line. So 2.3581 minus 1.8529. Okay. And the final number that you should have got out when you plug those in is 2.105. Okay. So for the rest of question one, all you need to do is to repeat this by changing the value of P in the formula for the percentile. So you just need to recalculate another value of R by putting the value of P that we need in here and continuing on. The only thing I would like to just mention, which will help us along, is we were asked for Q0.5, which is the 50th percentile, which you'll see in the final question of this exercise can be formally shown to be the median. So because we've got 25 elements, finding the median is nice and easy because we've got an odd number of elements in our sample. So we just know that this was the 13th element in the ordered sample, the one that was in the middle. So the 0, so the 50th percentile, so p equals 0.5, is often a bit easier for us to calculate. So I'd like to leave you again with another couple of minutes, maybe until by my clock it would be 9:18, I think, to finish all of the values for that question off, and just check if you were using a different method that you get comparable answers to what I did. So I'm going to give you 2 or 3 minutes there. If you already have those numbers, start thinking about the next part of the question, which was we were asked to decide whether or not this distribution is symmetric. So what could we do with the percentiles in order to assess whether or not we think the distribution is symmetric or not? Yeah, so I'm going to stop talking and give you about 3-4 minutes to work on that. And if you want to communicate with me in any way you would like during that time, feel free. Okay, so hopefully you've managed to do at least the next 1 or 2 of those, or just double checked your answers. Just to clarify, we've got the 75th percentile as 6.15, and we've also got the 90th as 14.53384. This one. And then the final part of this question was saying, is this distribution symmetric? So if these values were symmetrically distributed, we'd expect there to be them to have like a sort of similar kind of distribution to the left and to the right of their median. You know, key things we would expect would be that, for instance, the distance between the 90th percentile, So the distance between the 90th percentile and the median should be approximately equal to the distance between the median and the 10th percentile, and the same for the 25th as well. So we would expect basically the difference between the 75th and the median would be approximately the same as the distance between the median and the 25th. So that there's the same amount of information either side of the median. Now, if you compare the values that you've got in the first part of the question, you'll see that these are quite radically different. For the distance here between the 90th and the median, we've got something in the realms of about 11.6 for this one, whereas this one, this distance on the left-hand side of the distribution is more like 2.42. So we've got a distribution which kind of tails off, very, very heavily on the right of the median. So I think we can't really say that this one would be symmetric. So that's just one way of us talking about whether or not the sample looks like it's symmetrically distributed. And we will see from question 2, some other statistics that, or some other techniques that we might want to deploy when deciding whether or not something is symmetric. Okay. So next up, question 2. Now, again, we were given, I think, quite a lot of data points. N was equal to 20, and we've got a list of the ordered data points on the sheet. And the first part was asking us for this, these 5 points that would summarize the data. So we were being asked for the 5-number summary. And the 5-number summary has, well, 5 things in, one would hope, right? So the middle element of the 5 is the median, so the 50th percentile. And then we also have the other 2 quartiles, the 25th percentile and the 75th percentile, so the first and the third quartile. And we also have the minimum value and the maximum value. Now, Sarles has been very generous to us, and he has ordered the data for us already. So it should be fairly easy for us to find the minimum and the maximum of the values that he's given us. So if you just take a look at the sample, there you can see they're all nicely ordered. And the smallest one of them is going to be the minimum value. So this minimum value, I'd really hope, is 29.140. Unless they've all shook up and I need to order them first. And then I've been asked for the 25th percentile and the median and the 75th percentile. So I'm going to focus on doing this next one and commenting on how we can get the median in this case. And then I'm going to leave you to try the other 2 for a moment or so. So in this case, we've got, as I said, n is equal to 20. The first one we've been asked for is p is equal to 0.25. So we calculate r using these 2. 0.25 times 21, which is, one would hope, 5.25. So q hat of 0.25 is going to be, we're going to have to go for the 5th ordered element, and 0.25 the difference between the 6th and the 5th. Okay, so when I look at my sample, I'm going to have to count along to the 5th element in the ordered sample. Okay, this one's kind of in the middle, so it's kind of, you have to be a little bit careful with the spacing between the numbers to find the right one. We've got 36.571 and 0.25, the difference between the next one along from that and this one. So 38 7 minus 36.571. Okay. And if you crunch that out, you should be in the realms of 37.0325. Okay. So hopefully we can now replicate doing that really, really easily. We can find pretty much any of our percentiles that we want. So we've identified this one, the middle one, the median, the 50th percentile. It is not quite as straightforward as it was in question 1, because this time we've got an even number of elements in our sample. So there isn't one that's directly in the middle. I need to take the midpoint between the two that are closest to the middle. So I need to take the difference between the 10th element and the 11th element. So the midpoint between the 10th and 11th element. And we can see that the way that we calculate that from the percentile formula is exactly the same as how our intuition would suggest. So we'd be looking at 10 and then half of the 11th element minus the 10th element. And this is just exactly the same as what I was just describing. So we'd take the difference, we would take the 11th plus the 10th and divide by 2. So both of those give us exactly the same number, which is 41.186. Okay. So again, I want to just leave you with a couple of minutes to find the other two values. So to find the 75th percentile and the maximum value there, and just to verify that you get the same answers as I do up until that point. Okay, so if you've looked at the questions in advance, you're probably twiddling your thumbs at this point and quite bored. But if you haven't looked at them in advance and you're struggling to keep up with the little gaps that I'm leaving, don't worry about it. I would have expected, if you'd looked at it in advance, that it wouldn't be trivial for you to be able to do this. It would take you a minute or so to do each one, and just to make sure that you're getting the right numbers in the calculator and stuff like that. I mean, I'm terribly clumsy with my calculator, and it used to really screw me up as an undergraduate, being really clumsy with my calculator. So don't worry if you've not looked at the exercises in advance and you can't keep up with the little gaps. I'm just trying to make it not too boring for people who've already looked at everything. Okay. So in order to present a really nice consistent answer, I would really like you to, at the end of doing all of that calculation, to you know, rewrite your vector of the 5 summary statistics and like put the values in, you know, so that, you know, we can explicitly see, or Sarah Lees can explicitly see, if he's marking this type of question on your exam, that you know exactly what you were asked for. You were asked for the minimum, the 25th, the median, 75th percentile, and the maximum value. So present your work nicely if you can, like write out what you found at the end. So the second part of this question, we were asked for the mean and the standard deviation of the sample. Now, again, I think it was a little bit kind of, I wouldn't say it was a little bit harsh, but you know, it's a little bit maybe frustrating to do this with your calculator. Sarah Lees has asked us like not to use a computer program if we can get away with it this week, you know, so you did have to sit there and like accurately get all of the numbers in, which, you know, as I just previously said, was always causing me a lot of jip. What we were asked for the mean is we have to sum up all of the numbers that we've been given and divide by 20, because there's 20 elements there. Yeah, I can tell you what the final answer is. I'm not going to, you know, bore you senseless writing out the 20 values. So the mean is around about 40.6942. Well, it's exactly that. The second thing we were asked for was the standard deviation of the sample. So we were asked for S. Now, the thing that's easier for us to calculate is S squared, the variance of the sample. And in this case, the formula that I'm going to use is going to be this one. I'm going to, first of all, sum up over the squares of the sample, of each element in the sample, and then I'm going to subtract off n times the mean. Now I've already calculated what the mean is, so I can plug that one in. You know, that's my motivation for using this formula rather than the one that says, you know, x bar minus the mean, because, you know, I don't really want to be faffing around with minusing the mean each time and squaring them and everything like that. You know, as I said, with, you know, having a bit of a thing about using a calculator, I want to like reduce the number of errors that I can make, really. And then what we divide by is n minus 1. And, you know, this is the same as I was saying 2 weeks ago. The reason why we're dividing by n minus 1 is because we're dealing with a statistic which is about the sample, not about the underlying population. So we'd like an unbiased estimator for what the standard deviation is. So we want to divide by n minus 1 rather than by n. And this number is around about 30.54 something. Oh yeah, 325. And we need to take the square root of it to get the standard deviation, because we were asked for S, not S squared. And we end up with a standard deviation around about 5.52 something, to 27, etc. You know, it's going to be slightly different depending on how many decimal points you round it to. We should be getting fairly good at calculating means and standard deviation. Okay, so I've had a question about the previous question about why, when we're calculating percentiles, we add 1 when we're calculating the R. You know, which element to start from. And I think the intuition for this is easiest to see when we think about the middle one, about the median. When I've got the 20 values, if you go back and you look at, you know, the sample for this question, for question 2, we've got 20 elements there. And if we want to find which one is in the middle, there isn't one that's in the middle, because there's an even number of elements. So to have the one in the middle, we want to be looking at the midpoint between the 10th and the 11th. If instead there was 19, so let's forget about the biggest value there. then the one that's in the middle is going to be the 10th element, because we're going to have 9 elements below it and 9 elements above. Now, if I with my 19 elements, to get to the 10th element as being the median, what I would want to be doing is adding on 1 to get to 20, and then dividing by 2 to get myself to the middle element. So, I mean, that's how I'm getting to the median, and I can think, well, in a very similar way, goodness me, falling over myself there a little bit, in a very similar way, if I wanted to get to any of the other percentiles, I have to offset myself by the extra element in order to get myself to the right place. So you're sort of adding on the extra 1 to make sure that you center yourself correctly on your data points there. So I mean, that's a kind of intuitive kind of reason for adding on the extra 1, and you can see in practice why that works with the median there. I can possibly see from the fact that she's smiling that maybe Hayden's going to write a longer explanation of why we add on 1 in the comments. I'm not sure. Either that or she's finding the entertaining one or the other. Okay, so hopefully that addressed the issue of why we're adding on the extra 1, is because that's what gets us to the right result. Okay. For the third part, we were asked to draw a histogram, and we were given the fact that we wanted the intervals to be 5 elements long. And I'm really fond of tables, as you probably know from 2 weeks ago. I love tables. So the first thing with drawing a histogram that I usually start with is drawing myself a frequency table. This is particularly useful when I don't have ordered data, because I can do a tally as to how many are in each interval, and it sort of saves me from having to reorder the data manually. Obviously, if I'm reordering the data using R, that's much more easy. I can just use the function sort. But yeah, okay. So the first thing I'm going to do in order to address the histogram question is to draw myself a frequency table. I'm going to have the intervals that I'm interested in. I've got their frequency, and I'm going to have another column for the height of the density histogram. Right. Now, the intervals that I were given were 5 long, and they are open on the left and closed on the right. It doesn't really matter whether you have them open on the left and closed on the right, or the other way around, because I don't think we've got any values that are exactly on 25, 30, 35, etc. Okay, so, well, I've just written out, the relevant intervals there, because I've gone up until I've got to one that doesn't contain anything, or that's bigger than the biggest value in my sample. If I look at the sample, I can see there's 1 element in that first interval, so I'm going to have a frequency of 1. And with the second one, I've got 2 that are between 30 and 35, so I'm going to write 2 in here. And I should be continuing along those lines. If I add up all of the frequencies, I should have a total of 20 altogether. And that's particularly handy if I'm doing a tally, just to make sure that I'm on target and not lost any data. Okay, so somebody's asked, it just says 25 to 55, so it doesn't imply a left hand open, right hand closed. I think it's just conventional to sort of like do it that way round. You know, feel free to, you know, do it the other way around if you need, or, you know, if you so desire. But, you know, just make clear which way around it is and do it consistently, because it would be upsetting if we had 30 in the first interval and in the second interval. That would, you know, that would duplicate some of our data by accident. So, you know, just try and be really, really consistent. You know, yeah, convention dictates we do them this way around, but just make sure they're, you know, one way or the other. Yeah. Okay. So again, if I fill out all of these, I'm going to have 20 altogether. When I draw my histogram, I want the area under the bars to be equal to 1. And I know that the width of each of these bars is 5. So I'm going to end up with 20 times 5. If you know, if I just go up 1 for each of the data points, I'm going to end up with 20 times 5 under the histogram in general, which I know is, you know, quite a lot more than what I need. So I'm going to need to rescale those values by the width of the interval multiplied by the number of elements that I've got. Yep. So in terms of the height of the density histogram, what I want to do is I want to divide the frequency by the total area under the graph if I was to just use an increment of 1 for each of the elements. So I'm going to have 1 over 100, 2 over 100, etc. Okay. And the reason why it's 100 here is that's the width of the interval times n, which in this case is 5 times 20. Okay. So, you know, you should be able to, you know, count these up and you know, draw your histogram as well. I possibly don't want to do that, so I'm just going to show you my little notepad with the answers, with the answer on it. There we go. So I like dotted paper for this because it's easier to draw graphs on. So I finished filling out my table with the number of, by counting the numbers of points in those in each of the intervals, rescaled them by 100, and I've drawn my histogram. So you can see that that's 1 square up between 25 and 32, etc. It's nice to have dots because it makes it easier. So I hope that you got something roughly like that. I also hope that you'd know how to do it in R as well, that you'd know how to put the data in R. But I guess that's a focus of one of the other weeks. Lesson 1, 2. Okay. So, cracking on. The next part we were asked about was about symmetry. And we were asked, do we think that this data looks symmetric? And I think that there's 3 possible things that we could look at. We could look at whether the difference between the first and the second quartile is similar to that between the second and the third quartile. So we could look at these differences again. And we've calculated what the quartiles are in the first part, so we could look at those. We could also look at whether the median is similar to the mean. And we could also look at whether this histogram looks symmetric. So when we were asked about symmetry, I'd say focus on 3 separate things. So we could look at whether these differences are similar, whether this one is approximately the same as the distance between the 75th percentile and the median. Secondly, whether the median is similar to the mean. And then finally, whether our histogram looks symmetric. So whether when we look at our histogram here, whether if we're looking at where the median is, whether we think, oh, there's this relatively similar kind of shape on this side as there is on this side. And that can be a little bit deceptive because it really does depend on where we put the bands as to exactly how symmetric it looks. Now, this data, I think, is actually pretty damn symmetric. But because of where the bands are compared with where the median is, it looks a tiny little bit kind of like heavy on this side. But I think looking at the histogram in combination with, you know, whether or not these two look like similar values, give us the idea that this is pretty symmetric kind of data. So symmetry, yeah. Okay. So, yeah, I think it looks symmetric. Now, I've gone a bit slower than I would have liked to again. So I think what I would have liked to have given you the opportunity to do now is to actually look at doing a box and whisker plot with this data live, because, you know, you've been asked to do that in questions going forward, and I think it's nice to see, you know, what would happen if you do something asked on a later question with an earlier set of data, just to see what kind of happens. Because I've got to give back to Sarah Lee so we can continue with the next class, you know, I suggest, you know, if you've got 15 minutes, you know, before you need to do anything else on your schedule, do just take a look at that anyway. Say, well, you know, what would happen if I had to draw a box and whisker diagram with this data? What extra things would I need? So I think, you know, I do. The only thing I want to direct you there with is you need an estimate for the interquartile range, and you also need to have a threshold for your outliers to identify whether there's any outliers. Yeah, I'm going to add on those points. So if I was to do a box and whisker plot for this data, I would need an estimate for the interquartile range, and then I would need thresholds for the outliers. Which is usually the 25th percentile minus 1.5 times the estimate for the interquartile range, and a symmetric parameter on the plus side. And there I've got plus 1.5, the estimate for the interquartile range. And then the lower adjacent and the upper adjacent for the data are the smallest and the largest point, which are inside, you know, those thresholds. So I would also need the lower stroke upper adjacent. And once I've got those, as well as the summary statistics that I calculated in the first part, it should be really easy for me to draw a box and whisker plot for this data. You know, if you would like a little bit of something extra to do in the next 10 minutes or so, I would suggest taking a look at that. But I'm going to have to, you know, hand over to Sarah Lees for him to invite his next group in. Okay.
Thank you, Jenny.
Yeah, no problem, Sarah Lees.
So I would take over from here. Then.
Yeah, of course, yeah.
Have a good day.
You too. I'll see you on Thursday.
Yeah, thank you.
Thanks. Bye-bye.
Bye. Hello, guys. So my session is from 10 to 11 and 11 to 12. So you're most welcome to stay around if you want to see my working, right? So you're most welcome to stay around. You don't need to leave unless you want to. Okay. All right, guys. So. Hmm. Hmm. Good morning, guys. Good afternoon. Mm, hope you are well, guys. Um, all right. I'm disappointed with the number of people turning up. Don't know why it's so few. Um, um, anyway, okay. Today we're gonna do sheet 4, which is, if you go to the, let me show you. If you go to the website, um, uh, this is tutorial sheet number 4, right? There are 7 questions here. I will try to do as many as I can, right? Okay. So let me stop share. All right. The question number 1 is about finding quantiles or quartiles, right? I think these are kind of stuff I did in week 2. You may recall. So this is question 1. I mean, if you can't read this one, then I suggest you read the one on my course website. All right. So this is question 1. You're given this data set and you're asked to find the quantiles or quartiles at p equal to 0.1, 0.25, 0.5, 0.75, and 0.9, right? Okay. All right. So the formula, I don't know whether you guys remember the formula that I gave you some time ago. If you don't remember, I will write it down. This is the formula I gave you some time ago. Do you guys remember this or not? Where R is equal to P times n plus 1, and R prime is P times n plus 1, the integer part, right? Okay. So I'm going to use this formula to do question 1. Okay. Right. Okay. Now the first part is to find p equal to 0.1. Okay. So your n is the number of data points is 25, and p is 0.1. Right. So which means that r is 0.1 times n plus 1 is 26, which is 2.6. So your r prime is the integer part of 2.6 is 2. All right, so using this formula, q at 0.1 will be x. This means the second largest of the second smallest data, right? 2.6 minus 2, then x3 minus x2. Now this is the formula we need to use. And if you use this formula, you will get the answer 0.475. So this is the 10% quantile, right? Or the quantile corresponding to p equal to 0.1. Okay, guys? Any questions, just feel free to use the chat room, okay? The next one we want to find is p equal to 0.25, which corresponds to the first quartile, right? So your R is 0.25 times 26, which is 6.5, right? So your R prime is the integer part of 6.5, which is 6. So this will be like this, right? All right, guys. So if you work this out, you will get the value 2.1055. You guys okay so far? Just feel free to talk to me using the chat room if anything not clear. All right, the next one is p equal to 0.5, which corresponds to the median or the middle number. So your R is 0.5 times n plus 1, 26, which is 13, and your R prime is also 13, because the integer part of 13 is 13, right? So your Q at 0.5 will be x13 plus 13 minus 13. 13 minus 13 is 0, so this will be 0. And this is equal to 2.8957. All right, okay. And next is the p equal to 0.75, which corresponds to the third quartile. So your R in this case is 0.75 times n plus 1, which is 26. And if you work this out, this will be equal to 19.5. Okay, so your R prime is the part of 19.5 is 19, and your Q at 0.75 is x19 plus 19.5 minus 19, right? And then in brackets, x20 minus x19. Okay. Now, if you work this out, guys, you will get this to be equal to 6.15. Okay. Are you guys okay so far? Any questions? talk to me, guys. If any problems, just please feel free to talk to me. Okay. All right. So the last part we need to do. Last part we need to do is p equal to 0.9. So for p equal to 0.9, your r is 0.9 times n plus 1, which is equal to 23.4, right? So your r prime is the integer part of this, which is 23. So your q at 0.9 is 23 plus 23.4 minus 23. Then in brackets you have x. Sorry, this should be 24, guys. 24 minus 23. Okay. Now, if you work this out, this will be 14.53384. All right. So we found. I mean, so it's just a matter of using the formula, which is this one. I talked about this formula in week two of the classes, right? All right. There's also a question about whether the data is symmetric. Okay. If the data are symmetrically distributed, right, you would expect the distance between the median and the first quartile to be approximately equal to the distance between the third quartile and the median. Remember, this is the distance between the median and the first quartile. This is the distance between the third quartile and the median, right? They should be equal, at least approximately equal, if the distribution is symmetric. For the data that we just looked at, this is equal to 0.7902, and this is equal to 3.2453. And these two values are clearly not even close to being equal, right? So the conclusion is that the data are not symmetric. All right. So that completes question 1. Is that okay, guys? So before I go to question 2, are you okay with this or no? Or just saying, are you sure? All right. Thank you, guys. All right. All right. Now let's move on to question 2. Question 2 is, you have this data set here. There are 4 parts. The first part is to do the 5-number summary. I talked about the 5-number summary last week, you may recall. It's made up of 5 different summary statistics, right? So let me show you. So this is question 2, part 1. 5 numbers, the 5-number summary is made up of these values. The minimum is the smallest data point. So in this case, the minimum is these are ordered, so you can clearly see the minimum is the first data point, all right? So the minimum is 29.140. All right, the second of the 5-number summary is the first quartile. So your P is 0.25 and your R is 0.25 times n plus 1 is, you have 20 data points here. So your n plus 1 is 20 plus 1, which is 21. So this is 5.25. And your R prime is the integer part of this, which is 5. So your Q at 0.25 all right. if you work this out, guys, you will get this to be 37.03225. So this is the first quartile. All right, the next number in the 5-number summary is the median. So here you will take P to be 0.5 and your R will be 10.5, and your R prime is the integer part of R, which is 10. And so this will be this, yeah, using the formula that I mentioned in question 1. Now, if you work this out, this will be 41.186. All right, the next number in the 5-number summary is the third quartile. So you put P equal to 0.75 and your R is 0.75 times n plus 1, which is 15.75. And your R prime is 15, the integer part of 15.75. And your quartile will be this. Right? Now, if you work this out using a calculator, this is what you will get, 44.01975. So this is the third quartile. And finally, the final number in the 5-number summary is the maximum. So the maximum, if you look at the data, is the largest point, which is the last one, right? So it's gonna be 51.261. All right. So what I have written down, guys, are the 5-number summary. So this is the first of the 5 numbers, the minimum. This is the second of the 5-number summary, which is the first quartile. The third of the 5-number summary, which is the median. And the fourth of the 5-number summary, which is the third quartile. And the fifth of the 5-number summary is the maximum, right? All right, guys. So that completes part 1 of question 2. Now, part 2 is asking you to find the sample mean and the sample standard deviation. All right, let me show you how to do that. So to find the sample mean, I mean, it's really trivial. I mean, it's basically you need to. So this is question 2, part 2, right? To find the sample mean, you just add the numbers, right? And divide by the number of data. So you add all the numbers, all right? And you have 20 data points, right? Okay, so now if you work this out, this will be 40.6942. So this is the sample mean. To find the sample variance, you will use this formula. This is the unbiased version. Remember, I gave you 2 different formulas for the sample variance. And it's always a good idea to use the unbiased version, which has an n-1 in the bottom, right? The biased version, you don't want to use the biased version because it is simply, because of the reason that it is simply biased, right? Okay, now, now an alternative formula for this unbiased version, which I gave in the notes, you may recall, is this. I mean, actually, I actually proved this formula that these two are equal, right? And you may want to check the proof. I think it's in week 2. I think week 2 of the classes, I proved this. Okay. All right, now if you use this formula, because this formula is easier to use than this one, so that's why I want to use this one. All right, if you use this formula, this is what you will get. N minus 1 is 19, then plus sum of xi squared is like this. Then you have n is 20 times x bar we already know is 40.6942 squared, right? So this is what you get. Now if you work this out using a calculator, this will be equal to 30.54325. Okay. Now the sample standard deviation, which is denoted by S, is the square root of the sample variance. So it's the square root of 30.54325. And if you take the square root of this, you will get 5.527. All right, so this is the sample standard deviation, this is the sample variance, and this is the sample mean. All right, are you guys okay so far? Any questions, guys? Please feel free to talk to me using the chat room. Okay. All right. The next part of question 2 is to draw a histogram with each interval of width 5 ranging from 25 to 55. All right. Now let me show you how to do that. Now to draw a histogram, this is question 2, part 3. Okay. Now to draw a histogram, you need 3 different columns. I think I did this before in the class. You need the interval column, you need the frequency column, and you need the density column. The interval here, we want from 25 to 55 in steps of 5, right? So it will go like this: 25 to 30, then 30 to 35, 35 to 40, 40 to 45, 45 to 50, and 50 to 55. Okay, these are the intervals. All right, now the frequency is the number of data that fall in each of these intervals. So for the first interval, there's only 1 data that falls in this interval. The second, you have 2. Then you have this. Then you have this. Okay, so these are the frequencies in the intervals. Right now, to compute the density, I think I mentioned this before. The formula for the density is as follows. It's the frequency divided by the number of data times the interval width, or the width of the interval. All right, so in this case, the number of data is 20, right? And the width of the interval is 5. So 20 times 5 is 100, right? So this will be, the density will be 1 over 100. For this, it will be 2 over 100, 5 over 100, 8 over 100, 3 over 100, and 1 over 100. All right, so this, you see what I've done. I used, this is the formula you should use to compute the density. That is, it's the frequency divided by the number of data, which is 20 in this case, times the interval width, which is 5. So you will get this as the density values, right? All right. Now, if you plot, the density column versus the interval column, this is what you will get. I hope you can see this, right? this is what you will get in the, so you can see on the y-axis you have the density column, on the x-axis you have the interval width, and the area below, the area covered by the density, that is this area here must add up to 1, right? That's always, you know, I'm sure you know from probability 1, which you took last semester, that any area of a probability distribution must be 1. So if you compute the area of these rectangles, this one, this one, this one, this one, this one, this one, and add them up, right, you will get the area to be 1. All right, guys. So that's how you draw a histogram, right? I mean, I drew this using R, but if you are to do it by hand, this is how you should do it, right? You should first compute the table and then plot this versus this, right? Okay, guys. All right, so that's part 3. Now part 4 is to comment on the symmetry of the distribution. So let me do that here too. So question 2, part 4. Right, to do that, I'm going to use the same fact that I talked about earlier, which is if the data are symmetric, right, you would expect the distance between the median and the first quartile to be approximately equal to the distance from the third quartile to the median. Now, for the data that is given to us, this is equal to all right, and this is equal to right, and if you compute these two using a calculator, which you may have, I don't have a calculator with me. So if you compute this, you will see that they are approximately equal, right? These are approximately equal. So the data are approximately symmetric or symmetrically distributed. Right. All right, guys, so this completes question 2. Are you okay with this or not? Talk to me, guys. Are you okay with question 2? Or you want me to explain better? Sure. All right. All right. Just, I mean, if you have even a little doubt, I mean, just try to ask me, because I'm here to help you guys. You know. Okay. So even a small doubt you may have, just try to ask me. Harry is asking a question. Yeah. This is the histogram, Harry. So as I said, the y-axis is the density column, the x-axis are the intervals. Yeah. So, and the area below the covered by the histogram must add up to 1. All right. Okay. All right. So let's do question number 3. Question number 3 is about this table here. I hope you can see. If you can't see this, just look up on your laptop. Just open the tutorial sheet using the laptop, right? If you can't see this, right? There are two parts to question 3. Let's do part A. Part A is basically asking you to compute the density at x equal to 20 and x equal to 80. So let's take the case x equal to 20. So the density, as I said a second ago, the density is the frequency divided by the number of data, right, multiplied by the interval width. Right? Okay. Now, x equal to 20, if you look at this, x equal to 20 falls in this interval. Can you see this, guys? I mean, all right. So the frequency corresponding to this is 142, right? And the number of data is 500, and the length of the interval from 15 to 20 is 10. Right? So this, if you compute this, this will be equal to 0.0284. Right? Do you follow what I've done, guys? So I'm just simply applying this formula, right, and using this table here, right? Now let's consider the case x equal to 80. All right, in this case, x equal to 80 falls in this interval here. Can you see this interval? So 75 to 80 has a frequency of 6, right? So the frequency is 6 divided by the number of data is 500 times the interval width is 10. Right? So now if you work this out, this will be 0.0012. All right, so it's very easy to apply this formula with the table, right? All right, so that's part A. Part B is asking you to do the same thing, but this time using intervals of length 20, not 10. I mean, here we use intervals of length 10, but here we want to use intervals of length 20. So what we're going to do is the following. Let me show you using a color. We're going to combine two of the intervals. So the new table will be like this. You see what I'm doing? I'm combining two of the intervals at a time so that you get an interval of length 20. Right? Okay, so now let's redo the calculations. Now for x equal to 20, excuse me, for x equal to 20, the density is gonna be, right, x equal to 20 will fall in the first interval, right, from 5 to 25, right? And the frequency is 83 plus 142. So it's gonna be 83 plus 142 divided by 500, the number of data points, times the interval width now is 20. Now, if you work this out, this will be 0.0225, right? And for x equal to 80, now x equal to 80 falls in this interval, right? And that has frequency 13 plus 6, so 13 plus 6 is 19. So using this formula one more time, you have 13 plus 6 divided by 500 times 20, which is 0.0019. All right, you see what I've done now. So in part A, I have used intervals of length 10. In part B, I have used intervals of length 20. But it hasn't made a lot of difference to the densities. This is the density at x equal to 20 when we used interval of length 10. And this is the density when we use intervals of length 20, right? And this is the density when x equal to 80 with interval of length 10. and it becomes this when the interval increases to 20. So comparing this with this, you see it hasn't changed a lot, and similarly this hasn't changed a lot, right? So what you see is the following, that the density values are similar for the two interval widths, right? That's what I said, that increasing the interval width from 10 to 20 has not changed the density values much, right? Okay, that's what you would expect anyway, right? So, I mean, okay. Any questions on this, guys? So this is question 3. We just finished question 3. Right? Are you okay with this, guys? Hello. Talk to me, guys, please. Are you sure? All right. Next, let's go to question 5. Question 3. We have just finished question 3. Right. Next question is question 4. Question 4 is outside the syllabus because it's not something I covered in the course. So don't just skip question 4. I will not ask anything similar in the exam. Right. So let's move on to question 5. This is question 5. Next one. Question 5, it has three parts. The first part is to calculate the 5-number summary, which we already know how to do it, right? So let me show you how to do it again, right? So this is question 5, part 1. All right, the first of the 5 numbers is the minimum, which is the first data point, which is 31. These data are ordered as before. So the smallest is 31. The second of the 5-number summary is the first quartile, p equal to 0.25. So your R is, there are 18 data points. Your 18 plus 1 is 19. So this is 4.75. And your R prime, which is the integer part of this, which is 4. So your Q at 0.25 is, using the formula that I mentioned before, this is what you will get. All right, this is what you get. And if you work this out, this will be 69.75. Okay. All right, the next thing is the median. So your P is 0.5 and your R is 0.5 times n plus 1, which is 19. So this is gonna be 9.5. And your R prime will be the integer part, which is 9. So your Q at 0.5 will be this, right? And if you work this out, this will be 78. All right, the next of the 5-number summary is the third quartile. So you take P to be 0.75. Your R will be 0.75 times n plus 1, which is 14.25. And your R prime will be the integer part, which is 14. So your Q at 0.75 will be this. right? This is 115, okay? Okay. And if you work this out, this will be equal to 87.25. And the final number in the 5-number summary is the largest data point, or the maximum. So if you look at this, the largest data point is 94, right? So this is 94. All right, so just to highlight one more time, the 5-number summary is made up of the minimum, the first quartile, the median, the third quartile, and the maximum. So these are the 5 numbers, right? And the question is also asking you for the interquartile range, which is the IQR. Remember, the interquartile range is defined as the difference between these 2 numbers, right? And this will be equal to 17.5. Now, if you take the difference between this and this, you will get 17.5. Yes, you are right, Chen. Yeah, Q at 0 is the minimum, Q at 1 is the maximum. You are right. You are correct. All right, so that's part 1 of question 5. Part 2 is asking you to draw a box plot. All right, this is where things get interesting. Now, let me show you how to do a box plot. I think I showed you this in the class, but let me show you with this example, right? Now, if you do a box plot of this data, it will look something like this. Let me explain. Let me explain what these things are, right? Let me take just a few minutes. There are, okay, this guy here is the median, right? So in other words, this is Q at 0.5, which we worked out to be 78, right? And this guy here is the first quartile, or the Q at 0.25, which we worked out to be 69.75, right? And this guy here is the third quartile. In other words, Q at 0.75, and it's equal to 87.25. Okay. Now this one here is known as the lower adjacent, and this is the upper adjacent. Now, before I can talk about this, let me do the following. I need to compute the lower fence and the upper fence before that. All right. So remember, the lower fence, I think I mentioned this in the class. The lower fence is the point where the distance from the lower quartile to this is equal to 1.5 times IQR. Right. So if you take this distance from the lower quartile, you will get to this point, and this is known as the lower fence. This is known as the lower fence, and for this data, this will be equal to 43.5. Okay, and similarly, you should take the same amount of distance. You should take the same amount of distance, right, from here to up to here, right? If this distance is 1.5 times IQR, right, then this value here is approximately 113.5, and this will be known as the upper fence, right? So this is the lower fence and this is the upper fence. Now, okay, let's get back to this one. This is known as the lower adjacent. The lower adjacent is basically the data value that is just above the lower fence. In other words, what I mean is the following. That is, the lower adjacent, right, is defined as the smallest data that is greater than 43.5. 43.5 is the lower fence, right? Right. So in this case, this corresponds to the lower adjacent corresponds to 63. You can actually see 63 here. 63 is this value here, right? This is the 63 is the smallest data that is greater than 43.5, right? And similarly, this is known as the upper adjacent. The upper adjacent this is known as the upper adjacent and is defined as the largest data that is less than 113.5. 113.5 is the upper fence, right? And it turns out in this case the upper adjacent is equal to 94, right? I got a question from Harry. How do you work out the lower fence? I just explained to you, Harry. The lower fence is 1.5 times IQR from this, right? That is the lower fence. So you should take the distance 1.5 times IQR from Q at 0.25. You get the lower fence to be 43.5. And similarly, the upper fence is the 1.5 times IQR from this point. This is the third quartile, right? So you get 113.5 as the upper fence, right? And the lower adjacent is worked out as the smallest data value that is greater than the lower fence, which is 43.5. And the upper adjacent is worked out as the largest data point that is less than the upper fence, which is 113.5. All right. Okay, I know it looks kind of complicated, but it's not. I mean, if you do a few examples like this, you'll be okay, right? So basically, the box plot has 7 different values. It has the lower fence, it has the the lower adjacent, the first quartile, the median, the third quartile, the upper adjacent, and the upper fence, right? So there are 7 different points that you need to work out to draw a box plot, right? Are you guys okay with this or no? I know it looks, any other questions on the box plot, guys? Are you sure? All right, okay. All right, so that completes, it doesn't complete yet, but it is part of part 2 of question 5, right? Now, the next thing we need to do in question 5, so let me take this away. By the way, one thing I forgot to mention is that there are two data points here which are below the lower fence. So these two are outliers, because remember, anything that falls below the lower fence or above the upper fence is an outlier. So we have nothing above the upper fence, right? We have nothing above it, but we have 2 data points below the lower fence, this one and this one. So these 2 are outliers. All right. All right. The next thing, we still haven't finished part 2. So I'm still on question 5, part 2. It's asking you to comment. On the. Now, once again, if you look at the box plot, you can see that the median is approximately halfway. That is, this distance, and this distance, they are approximately equal, right? So because of this, you can say that the distribution is approximately symmetric, right? So that's what I'm going to say here. The distribution is approximately symmetric. It's approximately symmetric because the median appears all right. Okay, because the median appears halfway between the first and the third quartiles, as you can see here. It's not exactly symmetric, but approximately symmetric, all right? So that's question 5, part 2. Question 5, part 3 is asking you to compute the sample mean, which is you just add the numbers and divide by the total number of data, which is 18. So you get 75.06. And it's also asking you to find the sample standard deviation, which is, remember the formula I mentioned a few minutes ago. This is the formula I'm going to use to find the sample standard deviation, right? Now, if you work this out, guys, if you work this out, you will get this to be equal to 16.54. And you may recall that the median, which is Q at 0.5, is 78. Now, if the distribution is actually symmetric, you would expect the median and the mean to be approximately equal, but they're not. You see, the mean is 75.06, the median is 78. They're not, well, they are close, but not close enough. The reason that they are not close enough is because of this. The mean the mean, the one which is 75.06, is lowered by the two outliers. So if you look at the box plot one more time, these two outliers have brought down the mean, right? It should be higher than what it is now. The mean, currently the mean is 75.06, but it should be higher, but it is not. The reason is the presence of these two outliers. If these two outliers were not here, if they weren't here, then the mean would have been a lot more closer to the median, which is 78, right? Okay, but because of these two outliers, the mean is brought down to 75.06, right? All right, guys. So that completes question 5. Any questions? I mean, are you okay with question 5 or not? Guys, are you okay? I don't have time to complete the remaining 2 questions, which are question 6 and 7. But you will see the full solutions to all the 7 questions. I will post them online on Thursday, that is day after tomorrow. I will post all the solutions, the typed solutions, the handwritten solution, and also the video solutions for all 7 questions will be posted on Thursday this week. All right, so just you can go to the post website and check them on Thursday. All right, guys, so that completes this tutorial, but there is another tutorial from 11 to 12. So if you want to stay around, I'm happy with that. So there's a tutorial from 11 to 12 in a few minutes. So I'll see you guys shortly. Yeah. Yes. No. You need help? Hello guys, good morning or good afternoon. I don't understand why there are so few people attending classes these days. All right guys, good morning. So today I'm going to go through tutorial sheet 4. So if you look at the, if you guys look at the example, sorry, at the website for this course, which is this one, let me show you. This is the tutorial sheet number 4. So as you can see, there are 7 questions in this tutorial sheet, and I will try to do as many as I can today, right? Okay guys, so let's stop share. Okay, now let me change the camera. All right, so this is the tutorial sheet. I mean, if this is not clear enough, you can read it. You can read the sheet online. As I just mentioned, you can go to the course website and read the tutorial sheet in the course website. All right. All right, guys. All right. So let's start with question 1, which is this one. So you can see that you're given a data set. You're given this data set, and the question is to find the quantiles or quartiles at p equal to 0.1, 0.25, 0.5, 0.75, and 0.9, right? Okay, so let's see how we can do this. Now, the formula you need to use to do this question is something that I taught you in week 2, I think. So if you look at the week 2 notes, you will see this formula. Right, this is, you probably remember this formula, I don't know, where your R is P times n plus 1, and your R prime is the integer part of P times n plus 1. Okay, so this is the formula I gave you some time ago. Let me highlight it and let me highlight this in the box, right? Okay. All right, guys. Okay. Okay, guys. So let's do the first part. The first part is we want p equal to we want p to be 0.1. And by the way, our n is 25, and we want p to be 0.1, right? Okay. So your r will be p times n plus 1, which is 26. So this is 2.6, right? So your r prime, which is the integer part of 2.6, is going to be 2, right? Okay. So using this formula, your q at 0.1 will be this, right? And if you work this out using a calculator, you will get this to be 0.475, right? So that's when p equal to 0.1. The next thing we need to do is for p equal to 0.25, which corresponds to the first quartile, you may recall, right? Right. So in this case, your R is 0.25 times 26, which is 6.5. And your R prime is the integer part of this, which is 6. So your Q at 0.25 is right? All right, now if you work this out using a calculator, you will get this to be 2.1055. The next thing we need to do is the median. The median corresponds to p equal to 0.5, you may recall. So your R is 0.5 times n plus 1, which is 13. So your R prime is also 13, because the integer part of 13 is 13, right? So your Q at 0.5 will be x13 plus, if you use this formula, 13 minus 13 is 0. So everything is 0. So this will be equal to 2.8957. As usual, if you have any questions, just please use the chat room, okay? I mean, I'm happy to answer all your questions anytime, 24/7. All right, the next thing is p equal to 0.75, which corresponds to the third quartile. So your R is 0.75 times n plus 1, 26. So this is gonna be 19.5. Yeah. So your R prime is 19, the integer part of 19.5. So your Q at 0. Is gonna be equal to, using the formula, right? Okay, now if you work this out, guys, you will get this to be equal to 6.15, right? So that's the third quartile, right? There's one more thing to do is p equal to 0.9, right? So p equal to 0.9 for your R will be 0.9 times n plus 1, which is 23.4. Your R prime will be the integer part, which is 23. All right, so your Q at 0.9 will be R minus R prime, right? So this is x24 minus x23. Okay, now if you work this out, yeah, using a calculator, you will get this to be equal to 14.53384. Right, so that's completes all the working out that we need. But the question is also asking you whether the data are symmetric, or if the data are symmetric, you would expect the distance between the median and the first quartile to be approximately equal to the distance between the third quartile and the median, right? All right, so this one, using what we just calculated, this one is approximately equal to 0.7902, and this one, using what we just calculated, is equal to 3.2453, and these two are not even close to being equal, right? All right, so the conclusion is that the data are not symmetric. Okay, right, because if the data are symmetric, you would expect these to be approximately equal, but in this case, they're not even close, right? All right, so that completes question 1. Before I go to question 2, are you okay? Do you have questions on this, guys? Are you guys okay with this? Anything you like to ask, please feel free. Hello guys, talk to me. Guys, are you okay with question 1? Okay, thank you. All right, next question is question 2 is this one. You given this data set. You are given this data set and there are 4 parts. The first part is to compute the 5-number summary. All right, I will show you what, I mean, I talked about the 5-number summary last week in the tutorial, you may recall, right? The 5-number summary is basically, all right, it contains 5 different summary statistics, right? The first of the summary statistics is the minimum. So minimum is the smallest data. So if you look at this data, the smallest data is this one. It's actually arranged in the increasing order. So you can see this is the smallest data, which is 29.140. All right, now the second of the summary, 5-number summary is the first quartile. So it corresponds to P equal to 0.25. So your R is 0.25 times n plus 1 is 21. Because you see there are 20 data points here. So your n plus 1 is 21. So this is 5.25. Your R prime is 5, okay? So your Q at 0.25 is this. Using the formula that I just mentioned 1 minute ago, this is what you get. Excuse me. Okay, and if you work this out, this will be 37.0325. Okay. All right, the next number in the 5-number summary is the median, so corresponding to P equal to 0.5. All right, so your R is 0.5 times n plus 1, it's 21. So that is 10.5. So your R prime is 10, the integer part of 10.5. So using the formula, you will get this to be X right, this is the formula. If you work this out using a calculator, you will get this to be this, right? All right, next is the next number in the 5-number summary is the third quartile, corresponding to P equal to 0.75. So your R will be 0.75 times n plus 1, which is 15.75, right? And your R prime is the integer part, which is 15. And right, so using, hello guys, you have questions? So using this formula, you get all right, using this formula, you will get this to be equal to 44.01975, right? Okay, so this is the next one. So the final number in the 5-number summary is the maximum or the largest data point in the data. So if you go back to the data, because the data is arranged, the largest data point is this one, right? So it's gonna be 51.261. So these are the 5 numbers that the question was asking you about, right? So just let me highlight them. Just right. So the first number is the minimum. The second is the first quartile. the third is the median, the fourth is the third quartile, and the final one is the maximum. So these 5 numbers constitute what is known as the 5-number summary. All right, guys. All right. So that part 1 of question 2. Part 2. Okay. Now let me move to part 2. Part 2 of question 2 is asking you to compute the sample mean and the sample standard deviation. Okay, to find the sample mean, all you have to do is just sum all the data points. You take the sum of all the data points, right? And then you divide by the total number of data, which is 20. And this will be equal to, if you do the computations, this is what you will get. Right now, to find the sample variance, remember I gave you 2 different formulas for the sample variance. The one to use is always the unbiased version. Remember, the unbiased version has n-1 in the bottom. So this is always the better formula to use of the 2, right? Oh, 2, 1 again. Okay, sorry. Vincent, can you see this now? So 2, 1 is basically, these are the 5-number summary: the minimum, the first quartile, the median, the third quartile, and the maximum. I mean, you don't need to copy them down because I will post the videos shortly after. I mean, as you know, all the videos from every tutorial session are posted on the course website, so you can see them anytime later, right? All right. Now, another way of expressing this is as follows. I think I proved this in the class in one of the, I think it was in week 2. In week 2, I showed you that this can be re-expressed in this form, right? All right, so now n in this case is 20, so 20 minus 1 is 19. Now this is sum of xi squared, so this is like minus n x bar squared. N is 20 multiplied by x bar is 40 point. Right? Okay, now if you do this, you get right. So this is the sample variance, right? Now to find the sample standard deviation, you just take the square root of the sample variance. So it's the square root of square root of this, which is 5.527. All right, so this is the sample standard deviation. This is the sample variance, and this is the sample mean. All right, are you guys okay so far? Yeah. Any questions so far, guys, or not? All right. Okay. Next question. Sorry, the next part in question 2 is to draw a histogram with intervals of width 5, ranging from 25 to 55. Now, to draw a histogram, I think I did an example in the class. Now, what you need to do is the following. So this is question 2, part 3. So you need to, in order to draw a histogram, you need to have 3 different columns: interval column, the frequency column, and the density column. Right. The interval column, it goes from 25 to 50 in steps of 5. So the first interval must be this. The second interval is 30 to 35, 35 to 40, 40 to 45, 45 to 50, and finally 50 to 55, right? So these are the intervals, and now the frequency. The frequency is basically how many of the data points. So for this interval, there's only one data point, right? You can see it, I mean, you can see it here, like from the data, right? For this interval, there are two data points falling, 5, 8, 3, and 1, okay? All right, next, we need to find the density. To find the density, you will use this formula. I think I mentioned this formula in the class some time ago. So the density is the frequency divided by the number of data multiplied by the interval width. Right. In this case, the number of data is 20. The interval width is 5. So 20 times 5 is 100. Okay. All right. So this will be 1 divided by 100, 2 divided by 100, 5 divided by 100, 8 divided by 100, 3 divided by 100, and 1 divided by 100. All right, so you see we've done the necessary work. So the intervals, the frequency, and the density, right? All right, now to plot the histogram, what you need to do is to plot this versus this. Now, if you do that, this is what you will get. This, you will get this. So on the y-axis, you have the density. On the x-axis, you have the interval, right? And the area below the histogram, right, must be equal to 1, as it should, right? So the area covered by the histogram must add up to 1, as it should, because I'm sure you know from probability 1 that any area covered by a probability distribution must be 1. So if you work out the area of all these rectangles, right, and add them up, you must get 1, right? All right, guys, any questions on this? So this is how, I mean, I use the R software to do this, but if you want to do it by hand, if you want to draw the histogram by hand, you will plot this versus this, and you will get something looking like this, right? All right. All right, guys, are you okay so far? Okay, good. All right, the next thing, the next part is a final part to this question. The next part of question 2, part 4 of question 2 is asking you to check if the data are symmetric or not. All right, now let me show you how to do that. All right, now to check, so this is question 2, part 4. Now, if once again, if the data are symmetric or symmetrically distributed, right, you would expect the distance from between the median and the first quartile to be approximately equal to this. All right. Now, if you compute this using what we just computed, right, this is equal to 41.186 minus 37.0325, and this is equal to 44.01975 minus 41.186, right? Now, if you have a calculator, you can work this out. Just work this out and work this out. You will see that they are approximately equal. All right, these are approximately equal, right? So the data are approximately symmetric. Okay. All right, so that completes question 2 of the tutorial sheet. Are you okay with this? Or do you have any questions? Just even a little question, feel free to ask me. I'm here to help you guys. Are you sure you're okay with question 2? Okay, all right, let me move to question 3. Question 3 is based on this table here, right? It's based on this table. I hope you can read. If you can't read this, just use the one on your laptop. Just open it on your laptop and you'll be able to read it better. All right. Now there are two parts. There are two parts to this question. The first part. So this is question 3. The first part is asking you to compute the density at x equal to 20 and x equal to 80. Right. So remember what I told you. The formula for the density is given by this. It's the frequency divided by the number of data, all right, times the interval width. Times the interval width. Okay. Right. Now, if you look at this this table, all right, the first table gives the interval. So the first column gives the interval, the second column gives the frequency, and the third column gives the percentages. All right. Now let's take x to be 20. X equal to 20 falls in this interval here, right? This is the interval that corresponds to x equal to 20, right? I got a question from, I got a question from one person. Yeah, they are not exactly equal, but they are not too far off, because what you get is one is 2.8, the other one is 4.2. They are not, I mean, they are not too far off. I mean, you can say 3 and 4. 3 and 4 are not really, I mean, if you round them to integers, it's like 3 and 4, which are not far off, I would think. Anyway, let's return to question 3, right? So I'm using this formula and I want to find the density at 20. So 20 falls in this interval and the frequency is 142. So this will be 142 divided by the number of data is 500. That's the total number of data, times the length of the interval is 10, right? So if you work this out, this will be 0.0284, right? So that's the density, right? It's simple. It's just simply use this formula. Now, x equal to 80. For x equal to 80, again, use the formula. Now, 80 falls in this interval, right? And the frequency is 6, right? So it's gonna be 6 divided by 500 times 10, which is equal to 0.0012. So this is the density at x equal to 20, and this is the density at x equal to 80. Right, so that's part A. Part B of question 3 is asking you to do the same thing, but with using intervals of width 20. See, you see, this table has intervals of width 10, but we want to use intervals of width 20. Now to do that, you need to combine what you need to do is the following. You need to combine these intervals, 2 at a time. So combine these 2 intervals, you will get a length 20, 5 to 25. Combine these 2, you will get an interval from 25 to 45. Combine these 2, you get an interval from 45 to 65, and so on. All right, so you keep doing this. You see what I'm doing? I'm combining 2 of the intervals at a time, so that what you get is an interval of length 20, right? Okay, now let's get back to the question. Now, for x equal to 20, using the same formula, right? Now, x equal to 20 falls in this interval, right? And from 5 to 25, right? And the frequency is 83 plus 142. So it's going to be 83 plus 142 divided by 500 times the interval width is 20. All right, so this, if you do this is what you get. You follow what I'm doing, right? If you have, now for x equal to 80, if you go back to the table, 80 falls in this interval from 65 to 85. And the frequency is 13 plus 6, right? So it's going to be 13 plus 6 divided by 500 times 20, right? So this is going to be 0.0019. All right, guys, so you see, the purpose of this exercise is to see how the density values change when you increase the interval width from 10 to 20. So this is the density value when the interval width is 10. This is the density value when the interval width is 20. And as you can see, it hasn't changed much. 0.2840225. And this is the density value when the interval width is 10. And this is the density value when the interval width is 20. And again, it hasn't changed much. 0012, 0019. So the conclusion here, what you can say is that the density values are similar. They're not too different, right? For the 2 interval width. I mean, that's what you would expect, right? Because you don't want, you don't want the density to change much with the interval width. I mean, so here, that's what you are expecting, because changing the interval width from 10 to 20 hasn't changed the density values by a lot. Okay. All right, guys. So that completes question 3. Are you okay with this? Hello, guys. Talk to me. Are you have questions on the stuff I did just now? Yeah. Are you okay with question 3? Yeah. Thank you, guys. All right. So question 4 is outside the syllabus, so ignore that. So the next question I'm gonna do is question 5. Question 5 is this one. right? It has three parts. It has three parts. The first part, right? So the first part of question 5 is asking you to find the 5-number summary of the data, all right? And we already done that, right? But let me try to do it again. The 5-number summary, the first of the 5 numbers is the minimum or the smallest data, which is this one. So that's your smallest data. The second of the 5-number summary is the first quartile, right? So P equal to 0.25. Your R is 0.25 times n plus 1, which is n is 18. So 18 plus 1, 19. So it's 4.75. And your R prime is 4. So your Q at 0.25 is gonna be okay. Right now, if you work this out, this will be 69.75. So this is your first quartile, guys. The next number in the 5-number summary is the median. So your R is 0.5 times n plus 1, which is 9.5. So your R prime is the integer part, which is 9. So your Q at 0.5 is this, right? Okay. Now, if you work this out, this will be equal to 78, right? All right, the next number in the 5-number summary is the third quartile. So your P is 0.75. Your R will be 0.75 times n plus 1, which is equal to 14.25. So your R prime was the integer part, which is 14. So your Q at 0.75 is right, and if you work this out, you will get 87.25. And now the final number in the 5-number summary is the largest data point, or the maximum. Now the maximum is, if you look at this data, because it's arranged, is this one, right? So it's 94. So these are the 5-number summaries. So let me just highlight them one more time. So this is the minimum. This is the first quartile. This is the median, and this is the third quartile, and this is the maximum. So these are the 5-number summary, right? The question is also asking you to work out the IQR. Remember what IQR is? It's the interquartile range. So it's the difference between this and this, right? And if you take the difference between this and this, you will get 17.5, right? So that's the IQR. All right, so that completes first part of question 5. The second part is asking you to draw the box plot. All right, this is where the things get interesting. All right, let me show you how to draw the box plot. All right. I mean, I have already drawn it, but I mean, I will show you I mean, I have drawn this using R, the R software, but this is how you should draw it. This is how it will look like. The middle line here is the median, right? So this point here is Q at 0.5, which we worked out already is equal to. Let me show you. Q at 0.5 is 78. This is 78, right? Now this line here is the first quartile, or Q at 0.225, which is equal to 69.75. And this line here is the third quartile, or Q at 0.775, which is equal to 87.25. Okay, right now this guy here is known as the lower adjacent, and this guy is known as the upper adjacent. Now before I talk about the lower and the upper adjacent, let me talk about the lower fence. You may remember what a lower fence is. Remember, you should take, okay, let me show you. You should take you should take this distance here, right? If this distance is 1.5 times IQR, right? So this, remember, this is the first quartile, and you should take 1.5 times IQR from this, and this becomes known as the lower fence. Becomes known as the lower fence. And for this data set, this turns out to be 43.5. Okay. And similarly, if you took the same amount of distance, you should take the same amount of distance, right, from the third quartile. That is, this distance is 1.5 times IQR, right? Then this line here, is known as the upper fence. Hope you can read my writing. Upper fence, right? This line here is known as the upper fence, and it turns out that for this data it is 113.5, right? You see what I've done so far. I've computed the lower fence, the first quartile, the median, the third quartile, and the upper fence, right? Okay, now let's get back to this. This is known as the lower adjacent. This guy here, this guy is known as the, let me write it here. This is known as the lower adjacent, right? And it is computed as the smallest data that is greater than the lower fence, which is 43.5 here. So it's the smallest data value that is greater than the lower fence, right? All right, so that gives you the level for the lower adjacent. And it turns out, you should look at the data set. You should look at the data set. This is 63, because you should go back to the data set. The smallest value in this data that is greater than 43.5 is 63, right? So the lower adjacent is 63, right? And similarly, the upper adjacent is given by this. This is the level of the upper adjacent, and is defined, the upper adjacent, right, is defined to be the largest data, value that is less than the upper fence, which is 113.5 in our case, right? So if you work that out, this will be equal to 94, right? Actually, if you go back to the data, which is this, right? You will see that the largest data value that is less than 113.5 is 94, right? All right, so the upper adjacent is equal to 94. All right, so this completes the histogram. I know it looks kind of complicated, but if you do a few examples like this, you'll be okay. So basically, you need seven values to draw a histogram. The first is the lower fence. This is the lower adjacent. This is the first quartile. This is the median, and this is the third quartile. This is the upper adjacent, and finally this is the upper fence. So you need all these seven data points in order to draw a box plot, right? Are you guys okay with this or not? Or is it confusing or what? Hello guys, are you okay? Talk to me, guys. Yeah, you sure? Okay. I mean, if you want me to go over this again, let me know. I'm happy to do that. Okay. Okay. Yeah. All right. So this is the box plot. Now there's a question about the box plot. So this is I'm still on question 5, part 2. As you can see, the distance, this is the distance between the median and the third quartile. This is the distance between the median and the first quartile. They are kind of, although they're not exactly the same, they are approximately equal, right? So you can say the distribution is approximately symmetric, because the median is the middle line, guys. The median is approximately halfway, right, between the first and third quartiles. Okay, so that completes part 2. Now part 3, the part 3 of question 5 is asking you to compute the sample mean and the sample standard deviation. The sample mean is basically you take the sum of all the data, right, and divide by the number of data, which is 18. So this will be 75.06. Now to compute the sample standard deviation, you take the square root of the unbiased version of the sample variance, right, which is, remember, this is a formula I mentioned a few minutes ago, right? Now, if you work this out, this will be equal to 16.54. So this is the sample standard deviation, this is the sample mean, and the sample median, which we already worked out earlier, was 78. Right, now, okay, if the distribution is symmetric, then you would expect these two to be approximately equal. But they're not exactly. I mean, they're not exactly. They're not. I know it's not. They're not far off, but yet they're still not. You would expect this to be closer to 78. But the reason that this is not closer to 78 is because of the following. Now, if you go back to the box plot, you will see this. You see there are two data points here that are below the lower fence, and because they are below the data fence, they must be outliers, right? Remember, a definition of an outlier is that anything that is below the lower fence or anything that is above the upper fence is an outlier. So in this case, you have two outliers, right? And these two outliers have the effect of pulling down the sample mean to 75.06. I mean, if we did not have these outliers, right? Then if we did not have these outliers, then the sample mean would have been a lot closer to the sample median. But it's not, because of the reason that this is 3 points below the sample median is because of the outliers. All right, so that's what I'm going to say here. The mean, the value of the mean is affected by the two outliers, right? Right. I mean, because of the two outliers, the mean is brought down. I mean, it's not too far off, but it's still 3 points below the median, right? And without those outliers, it would have been a lot closer to the median. All right, guys, so that completes question 5. Are you okay with this or not? Hello, guys, talk to me, please. Are you okay with question?
这要啥？我一会儿还可以，一会儿还上104，你把
啥字呀？
我要4呀。
那还得唱。
你一会儿就该对，你一会儿就该睡觉。
Hello, guys.
我看啥可？
All right, guys. So you're okay with question 5? Okay. All right. The question 6 and question 7, I don't have time to do it today. I apologize for that. But you will see the full solution. You will see the full solution to all the 7 questions. You will see the full solution to all the 7 questions posted on the course website on Thursday of this week. So you will see the typed solutions, you will see the handwritten solution, and you will also see the video solution to all 7 questions. I will post them in 2 days' time on Thursday afternoon, right? Okay, guys, you have a good evening. Sorry, have a good afternoon or good evening or good morning. So I'll talk to you soon, guys, right? Any questions you guys have, please feel free to contact me 24/7 by email, Skype, Zoom, or phone. You know my phone number is 0161 273 2941. That's my home phone number. Okay. All right, guys. Have a good time wherever you are. I'll talk to you soon.